Seriously, what is up with this? It's almost April. We had like 6 inches of snow Tuesday. And it's freaking snowing again. I'm done with snow. I should move to Florida. So let's go in the shop and make another video. Alright, now we're going to talk about tool bits. It's grinding lathe tool bits, or at least the way that I do. There have been many people that have done these videos and have explained it a lot better than I ever could. Mr. Pete Tool Kane is one of those. He has quite a few videos up, I believe, of tool sharpening, at least 3 or 4, and he goes through all the different types, and it's very, very informative, and I do suggest you take a look at that. All of his, I believe, is based off of pretty much Southbend's How to Run a Lathe, which has lots of information of tool bit grinding. If you don't have it, pick it up if you want to know about that. But there are lots of places to get info from. I believe that this is one that I got from the class I'm taking. This is out of a Navy manual, I'm pretty sure. So, first things first, I'll talk about tool bit materials. And I am going to throw out the debate of high-speed steel versus carbide. Okay, personally for me, carbide, at least on my lathe, is useless. Many would disagree. Alright, the reason why it's useless on my lathe is carbide is generally used for hard materials that will destroy destroy high-speed steel. And actually any material, but they're mainly used, or originally came around because of the toughness of some materials, and also be able to turn at a higher speed and not heat up and destroy the cutting edge. Now, the only way to take full advantage of a carbide tool bit is to turn your stock really, really fast. My lathe here is only the 6-speed lathe. In other words, I don't have the second step on the motor drive, on the motor to the countershaft pulley. There is another version that does have a second step on that. The highest speed my lathe is able to attain is anywhere between 650 and 700 RPM. There's the other version of the 9-inch, I believe, goes up to around 1200 RPM. Now that is more suited for carbide. Carbide, if you look in any machinist manual, machinist handbook, you'll look and it'll show your speeds and feeds for different materials, and you'll see the major difference in speed, in turning speed, from a carbide tool bit to a high-speed steel tool bit. So for me, it's useless. Also, the other thing with carbide is grinding. You'll need a diamond stone for it. You'll need or a diamond wheel rather, and to be able to grind the carbide. And that for me is just not cost effective. Also, the bits themselves are relatively expensive. I mean, you can go to Harbor Freight and get the box for like 15 bucks, but honestly, have you ever looked at those? They're pretty nasty stuff. Then they also have the inserts, carbide insert tooling, which again is quite expensive because you're paying for the holder for this, and then you're also paying for the individual inserts. So for me, it's useless, and also for somebody starting out, I suggest, highly suggest, to stay away from carbide. High-speed steel, you'll have is less finicky than carbide. You can get, it's easier to get a better finish on high-speed steel. Also, high-speed steel is turned a lot slower, so if you do screw up, at least you're turning that piece of stock at 1200, 1300 RPM. You're only, 300-400 RPM. You're not going crazy with it. So I suggest if you're starting out, go to high-speed steel. This bit alone will honestly last you a friggin' lifetime, and it's $3. So I highly suggest the high-speed steel, especially for a beginner. Now, I have just go over tool holders real quick. I have the Phase 2 AXA Allura style tool holder. Now you notice it holds your tool bit perfectly flat and at a 90-degree angle to your tool post. And then to adjust this angle, you can swivel your whole post. Now a lot of you are going to have the lantern tool posts with the Williams holders, which are these here. Now you can see that these have a direction to them. So you have a straight holder, you have a left hand tool holder, and a right hand tool holder. You notice that the right hand tool holder points to the left hand tool holder points to the right. Easiest way to remember which one's which. Take your arms, point them straight out towards you, point your fingertips into each other. Your right hand looks like a right hand tool holder, your left hand looks like a left hand tool holder. That's the easiest way I've ever found to remember it. The other thing you have to be aware of, when I talk angles, grinding angles, and especially on the end clearance on the front of the bit, these tool bits, let me get something flat here just so you can see. Zoom in actually. It's probably easy to put it in the straight to see what I'm talking about. Okay, these tool holders here, I don't know if you can see, get a better shot here. Alright, you can see that this bit is automatically pointed up at an angle. I believe that angle is 16 degrees, something around there. So when I say I grind a 15-degree clearance on the front of the bit, you're going to have to grind a little bit more, because you have to be aware that that is tilting that edge up to the 16 degrees. So you'll have to be more than that 15 degrees, otherwise your heel of your bit will dig in. Also, on your form tools, like your threading tools, you want your threading tool to be presented to your work perfectly flat. Now you can't do that with one of these. You're always going to be at an angle, so what you would have to do is take 16 degrees off the top of this and flatten it out. It's just something to be aware of when you're grinding these. Alright, the next biggest thing to know is direction of cut. When people are talking about right hand, left hand tool bits, what are they talking about? Okay, a right hand tool bit is this here, and basically right hand tool bit will cut from your right to your left, from your tailstock towards your headstock. Left hand tool bit, just the opposite, will cut from the headstock to the tailstock, from your left to your right. Easiest way that I have found to remember that is wherever your cutting edge is, this rake and clearance angle, wherever that is pointed, that is the direction of your bit. So in other words, this is pointing down into the right hand bit, down into the left hand bit. Or you can also say opposite of your cutting edge. So in other words, cutting edge is on the right side, that's a left hand bit. Cutting edge on your left side, that's a right hand bit. That's a little more confusing in my opinion. Now, tool bit grinding is a very, very touchy subject, because everybody has their own way of doing it, and everybody's way is right. Basically, the only thing that is wrong is when you grind a tool bit that won't cut the material you want to cut. That's basically it. The only thing the angles are there to do are to create clearance of your cutting edge and to prolong tool life. So as far as going, I've seen people make up these crazy jigs to get the perfect 8-degree angle, 10-degree angle. In my opinion, that's useless, because all you want to do is take this cutting edge here and make enough angles so that it's basically presenting only this edge to the work. That's all these angles are. All this cutting here, this cutting here, this cutting on the front. The only reason that exists is to get this cutting edge and only this cutting edge in contact with the work. That's it. That's the whole premise of tool bit grinding. Now, as far as angles go, rule of thumb: the tougher your material, the less this angle is going to be. Alright? The less this side rake is going to be. The gummier the material, the more that's going to be. Also, if you like grabby materials such as brass, you'll have no rake on the top, because if you put a rake on it, it'll tend to want to dig and roll under. Now, what am I talking about when I'm talking about clearance in rakes? Okay, sides of a tool bit. Let me get a pointy. The angle from your cutting edge here, down and away, that is called side rake. The angle from the front of the tool bit to where your grind stops, from here to here, is called back rake. The angle from the front of your tool bit down towards the heel, down and towards you, is called end relief or end clearance. The angle from your cutting edge down into your right, or down and away from the cutting edge, is called your side relief. This side relief here is there to prevent this section of the tool bit from touching your work. This end relief, front clearance here, is there to prevent this front corner from touching your work. This back rake here, or side rake rather, here, this here, is to prevent this side from touching your work, and also as it's to present this tip or this edge up into the work, so when the work comes in contact, it'll actually slice and peel off a curl. Alright? The back rake, which my bits don't have, and I'll show you why, from here to here, is there to prevent, to ease your cutting pressure. In other words, the rake here will require less pressure to cut because you're only presenting this one little tip to the work. Now, there's a reason why I don't do that. And then, you know, if you take a deeper cut, your rake will be kind of like that. So as you present the deeper cut, it'll kind of want to chip and slice into the work. It just makes an easier cutting edge. But you'll see why I don't do that on most of my tool bits. I do it on some of the aluminum stuff, just because that's kind of gummy and that it takes a little bit of pressure off it, but you'll see why I don't do that. Alright, so now as far as angles go, for me at least, this works for me. If you've been grinding tool bits for 20-something years and you have a way of doing it and it works for you, don't change. I'm not asking you to change. I'm not saying that my way is 100% correct, but it works for me and it does what I want it to do. This angle here, this front relief here, right here, I like that angle anywhere between 10 and 15 degrees. This side clearance here, I like this, again, about 15 degrees. This side rake, I like 15 degrees. This angle right here, this clearance angle right here, which is the edge of cutting angle, something I forget what the actual term for that angle is. There is a term for it though. This angle right here, I like that around between 10 and 15 degrees. Now you can see I do that for ease of grinding. I have my table on my grinder set at about, it's actually around 12 degrees because I have little indents in it on the knob, and it ends up being about 12 degrees, which is fine for me. So when I grind it, all I would have to do, picture this as my grinding wheel, is that's the table's already tilted. All I would have to do is take my blank bit and touch it just like this to grind that angle. Alright? Then to grind the side, it's already at 15 degrees or 12 degrees, is just resting on my table, grind that angle right in place. Then this top, flip it over and grind that right into place. And those angles work out pretty good for me. If the bit isn't doing something you want, then you can adjust the angles relatively easily. Just kiss an edge, put a little bit more relief if it's not giving you enough of a chip curl, or if you're rubbing, add a little bit more relief in the end, or if you need to get a a certain angle into a corner, grind away an edge, or even if you're doing a harder material and you're not getting the finish that you want and it's just galling, a little less rake on the top, make it a little bit more stiffer. Or even if the cutting edge here is dulling on you too quickly, a little less relief on this end here will strengthen that cutting edge. So the grinding is all a combination of getting the finish you want and getting the tool life you want. You can get a great finish by grinding a huge relief here and here and putting a huge radius on the end, but you're not going to get a good tool life out of it. You're going to have to be touching it up every 10 seconds. So that's kind of the way I do it. And most of my tools, like I said, are just like that. This here, right hand bit, sorry, is a mirror image of the left hand. And they're all ground exactly the same. Like, I don't put any rake in my bits because, let me see if I have one that has a rake in it. Or I usually don't. I wouldn't say I always do. Here you go. Here's one with a back rake in it. Now, problem with the back rake is, I mean, it'll take less tool pressure to cut. But when you go and grind it, you can see as I grind it to sharpen it, I'm going to get less and less of a bit until I'm only 2/3 of the length I was before as I grind this down. So that's why I don't particularly do it. I do it in aluminum and some of the 12L14s because it gives a really good finish, but mostly my tool bits, here's my facing bit, are ground without it, and they work perfectly fine. So this one is this one here will be a left-hand tool bit because you're going to be facing, so I want to be able to feed into the work. Now, oops, I knocked the camera over. Now, some other types of tool bits. This is generally the one that I use the most. This shape here is pretty much what I use the most often. Now, a variation of that, and it's also in the how to run a lathe and everything else like that, is this one. And it has exactly the same thing, except for this angle here is about 20 degrees. Now, what that does is this will give you a lot greater clearance of that cutting edge around the side here. These will tend to be able to remove a lot more material in a pass than these, but won't give you as good of a finish. You can still put a radius on it, but I do find, at least for me, that something that's like this here gives me a little bit better finish than this. You can see they're pretty much almost the same. The only difference is you knock your cutting edge back a little bit and give you a bit more clearance on the end. That's it. Because all what that's doing is actually, as it's cutting, is actually, because of that angle, getting more of this cutting edge in contact with your work. They do work. They work pretty good. They work for removing a lot of, more material than this per pass. But I can still remove 100 thousandths of material with this, with ease, you know, with no problem, as long as I go with a decently slow feed rate on the smaller lathe. Now another one, and this is kind of hacked a little bit because I cut it on the bandsaw, but it's basically supposed to pretty much look like this, and that's it. This is a representation of it. You see a cutting edge is here. Now with this angle here, between here and here, is less than 60 degrees, 55 degrees or so, and you still have the 15 degrees on the side and 15 degrees on the sides, and then 10 or 15 on the top. Now what this is for is, if I can grab, this is for two things. You have a center in there, right? This bit, because it's less than 60 degrees at the end, will let you get in between your center and your work and face out and clean up that edge without touching the edge of your center. This tool bit will also allow you to get into a shoulder. If you need a sharp shoulder for any reason, if this diameter was smaller than that, you could actually get in and do all your work with your regular tool here, with this here, which will be presented to your work like this. Now you'll have a radius in the end, depending on how big of a radius you have here. This will allow you to get in, corner that, and face out, and give you a sharp edge. This is the tool that I used to make the bushings on the dial, so that there was no radius in the edge where it met the thread, so it touched it sat flush against the compound for me. Now another bit here we'll talk a little bit about is boring bars. Let me move this out of the way just so you can see it a little bit. Here is a tube. You're looking at it head on. Okay? Now, if you were to make, or actually if you were to use one of these boring bars here, your bit fits in like so. It wouldn't be that long, but it fits in like that. Now, what you need to do is grind yourself a regular left-hand tool bit, because you're going to be presenting into the work this way. Alright, you're going to be feeding in like this. Turning this way, you're feeding in this way. But what you have to do is grind clearance on the bottom of it, and I'll show you why. As you're feeding in, you can see the radius of your tube or your bore. If that tool bit were square, your heel would be digging into the edge. So you have to grind a clearance angle on it to be able to not rub against the bottom. Also, another good practice with boring is go slightly, and I mean slightly, above center on your turning. So as you come in, you're presenting just like a regular tool would. Just like this is what you're presenting to the inside of that bore. But you have enough clearance to not rub around everything. Now a variation on that, if you don't want to use one of these, you can also make your own out of a square tool bit, a square tool blank, like this one. And what you do is you grind a whole bunch of clearance on the bottom. That is the same thing as this. Alright. You're grinding a regular right hand tool bit but you're going to nick the edge around here to create clearance, so that when you feed in like this, you're not rubbing the end of your tool up. It's still a regular tool bit on the end. Still got the side rake, but this clearance will allow you not to rub the inside of your bore. And as you're coming through, you can also see that because you rounded off the edge here and this edge, you're not rubbing. Now, you don't have to really do the clearance on this edge, but it's just easier when grinding to rock it back and forth than it is to hold it like that. You just rock it back and forth on the grinding wheel, and you'll end up with something that looks kind of like that. Now, the only thing is, you'll only be able to go in as far as you grind your clearance back. Now, let me show you a commercially made high-speed steel boring bar. You can kind of see, here's your round shank, you got all the clearance there, and there's your cutting edge right there, right at the front here. That's your cutting edge, and it already has on the end, there's your rake angle. So you're basically making this shape here. Zoom in a little bit. You're making this out of a square bit. Now, one very, very special bit that we're going to make, or I'm gonna make. I've never made one of these before. I just found out about it. I think I first saw it on Gadget Builder website, gadgetbuilder.com. He has a mini lathe, and he does lots of a lot of modifications, a lot of good projects on there. It's actually where I got the design for the tangential tool holder that I'm currently in the process of building. But look up on his website, it's called, which I'll put a link to it right in the bottom here. It's called I think he calls it a vertical shear tool, and basically here is what it looks like, and it looks like nothing you've ever seen before, and it's supposed to give you really, really, really good and really fine cuts. It can't take a deep cut. It can only take a couple of thousandths, but it's supposed to give you a really, really, really good finish, and you'll see why. You have about 15 degrees of clearance here at an angle from his 90 degrees. You have about 15 degrees this way. Then on the front, from top to bottom here, you have 15 degrees. Now this is held into your work just like this, with the smaller part on top, the larger part on the bottom. So here's your work here, and as it goes through the work and your work rotates, you're not cutting against just the top edge here, you're cutting against all of this. And actually, this doesn't have to be, in other words, the tip of this isn't on center. The center of your work will ride probably somewhere in here. Now, as your work, I'm trying to get a decent angle here, as you feed into your work and your work rotates around, what's going to happen is the top of your work is going to hit here, and it's going to shear a piece off, just like a shearing action. And it gives you like fine, wispy, hair-like swarf, and it's supposed to give a great finish. I've never tried it before, but this is one tool that we're going to make. In the next installment of this series, we're going to make one of these, and we're going to test it out and see how it works. And then also in the next installment coming up in the next part of the video, I'll show you how to, or the easiest way that I've found, to be able to cut your high-speed steel bits to fit into your boring bar. And then I will also explain and show how to put a chip breaker in one of these, and my method for doing it. So stay tuned for that, and I'll hopefully have that up by this weekend. But hopefully you enjoyed this first little look at, you know, kind of going over how to do the tool bits. I know it was really quick, and I threw all kinds of weird angles and stuff at you, but just remember, for me at least, it's basically one angle. 10 degrees and 15 degrees. Well, 10 degrees on the front, 10 degrees from end clearance here, 10 degrees, 15 degrees side rake on the top, and 15 degrees clearance on the side. Those are the only angles you need. So 15 degrees, 15 degrees, and 10 degrees. And that's the basis of all my tools. All my cutting tools are cut at first just like that, and if I need to adjust them, or if it's not doing what I want, then I'll adjust them from there. But that's where I usually start. So stay tuned for the next one, which I should hopefully have up in a couple of days. Hopefully you enjoyed this video, and I'll see you when I finish the other one.